Hey Panthers, we are moving on to the second half of chapter 5, and we are continuing our work with ratios and proportions, but now we are going to apply it to a little bit of geometry. We're going to be looking at shapes, specifically similar shapes, and how we use ratios and proportions to determine similarity. So what I would like you to do right now is actually to pause the video and go ahead and fill in the notes in this section, and then when you hit play I will continue to explain them. So go ahead and hit pause and push play when you have the notes finished. Okay, welcome back. For our vocabulary for this section, our first one is similar figures. Similar figures are shapes that have the exact same shape but not necessarily the same size. So they're similar because they are the same shape, but not necessarily the same size. Couple things to remember, and again it'll make more sense once you start to see some of the problems, but we have a similarity symbol that we use. This little curvy line here, this little symbol means similar to. So if I want to say A is similar to B, I would write A is similar to B. Again, the squiggly line means similar to. Another thing just to remember is that when we start labeling our shapes, we use different letters. Keep in mind that the order of the letters in a similarity statement are extremely important. Okay? Remember that the order that you write your letters is extremely important, and again I'll show you why here shortly. Another term we have is corresponding angles. Corresponding angles, basically, if you're looking at two similar shapes, let's say here, I know my picture's not great, but let's say this is a right triangle, and then we have this bigger right triangle. Now obviously they're not the same size, but they are the same type of shape for all that we know. They both have right triangles. The corresponding angles would mean if I had the vertices of the vertices of these triangles labeled A, B, C, and D, E, F, you notice here A is the right triangle. And if you look at our larger shape, which one is also a right triangle? Hopefully you notice that D is the right triangle. Therefore, A and D correspond to each other. They match up to each other. So corresponding angles are angles that match up to each other. And the same thing with corresponding sides. They're the sides that match up to each other in similar figures. For similar figures, if you're looking at two shapes and you want to determine if they are similar, it can't just be done by looking at it. You really have to do some math. And step number one, you should always start first with the angles. Okay? Similar figures are indeed similar if the angles are equal. The angles must be equal to each other. So if you have a square, okay, square we know is all 40 or 90 degree angles, and then we have another shape. This is a rectangle. Oh my goodness, this is a bad example. Let's go back. Let's do triangle again. If I have a triangle that has a 90 degree angle, a 40 degree angle, and a 50 degree angle. If I had a larger similar triangle, the angles are also the exact same, 90, 40, and 50. So when we're looking at similar figures, they are similar if the angles are also equal to each other. The angles have to be equal to each other. Now many times students think that, oh, it's a smaller shape, the angles are smaller, Indeed, that is not the case. So the easiest thing to check when you're checking for similarity is first check the angles. Now sometimes the angles will be labeled for you and sometimes they won't, but if they have the angle measurements there, check that first. Once you've checked that and you've found that the angles are all equal, the next thing that you should check are the sides. They are called edges of the shape. The sides aren't equal to each other, they are proportional. The side lengths are going to be proportional, and I'm going to show you in a minute how you set that up. Let's take a look. Here's example 1. It says to determine if each pair of triangles is similar, and if not, explain. So right now all we're doing is checking to see if the triangles are similar. So step number 1, we're first going to check that the angles are equal. Okay? So just checking. In my first triangle here, I have 65, 85, and 30. Now my other triangle must also have 65, 85, and 30. So let's check. 65, 85, and 30. So are the angles equal? Yes. Now we can move on to step 2. Step 2 says that the sides must be proportional. Okay? Here's how we're going to check that. What I would like you to do right now, Panthers, is make sure that you either have 3 or 4 different colored pencils or markers or pens next to you. If you don't have different colored items, you can use shapes. But go ahead and pause the video, make sure you have your calculator next to you, and either different colors or we can use shapes. Okay, now that you have the supplies that you need, take your first color or shape. Take a look at the largest triangle first. What I do is very methodical. I always first start and find the longest edge or the longest side. Okay? Taking a look at this first triangle here, which one is the longest side? Hopefully you're saying 24. Okay? Let's take a look at the second shape. Which side here is the longest side? Hopefully you're saying 18. Now again, when we say that figures are similar, we know that their corresponding sides end up being proportional. Would you agree that 24 and 18 are sides that correspond to each other? They're sides that match up. Hopefully you're saying yes because they're both the longest side. Okay. So here's what you're going to do. And again, matching up the corresponding sides and angles is often the hardest part of this assignment, so make sure you do a really good job. Hopefully the colors help you out. I'm going to start with my largest shape. The side that has 24 runs from P to R. Okay? If you remember back last year with geometry, when you label the sides, this would be labeled P, R. Now you also could do RP, okay? You could also do RP, so choose whichever one you want. It's the second step that the order matters. So this is side PR, and it is 24 yards. And PR, side PR, corresponds to this side over here, which is FH or HF. Now FH in this case is not going to be the same thing as HF because you have to match up the corresponding sides and angles. So let's go back up here. We wrote our P first. P is what angle? 65 degrees. Now let's go over here. I'm trying to determine if I write the F first or the H first. So P, which is 65 degrees, must correspond with another 65 degree angle. Which letter over here is also 65 degrees? F. So since P came first in over here, F also must come first here. So basically I am saying Okay, so P was my 65-degree angle, and F was also my 65-degree angle, so I wrote them first. Again, the order of your letters matter. They have to correspond. So F, 24 corresponds to 18, so this is going to be F to H. And the length of F to H is 18. So grab your calculators, or just do it mental math. Go ahead and simplify this ratio of 24 to 18. When you simplify it, divide both by 6 and you get 4 to 3. Okay? Now, you have to check every single side of your shape. So we're not done. Grab a different color. I'm going to grab green. And now let's use the information for a different side. So we have a three-sided shape here. We're going to do 3 different ratios. This time I'm going to find my shortest side. So I have 16 on the first shape and 12 on the second shape. Okay. So go back up to 16. Again, 16 is P to Q or Q to P. It doesn't matter which one you choose as long as you're consistent with the second one. I'm going to do P to Q. And that length is 16 yards. And over here, P again is the 65-degree angle, which comes first. So over here, again, F is a 65-degree angle, so I'm going to write F first. So again, P corresponds to F. So PQ is 16, which corresponds to FG, which is 12. If I divide both of those by 4, I also get the ratio of 4 to 3. And let's do our third side. This is 20, which is QR. Again, Q is the 85-degree angle, so find the 85-degree angle over here. Q corresponds to G. And this last length here is 15, and that's G to H. Simplify 20 to 15, and you get, once again, 4 to 3. Are these shapes similar? Do they have the same angles? Yes. And are all sides proportional? Yes. So yes, these are similar. Let's take a look at another one. Again, just looking at these, we're always going to start with the angles first. I have 60, 90, 30. 60, 90, 30. So it meets the first step. Step 2, we have to find corresponding sides. I'm going to start with the largest side on this one, which is 16. And the largest side over here is 8. I'm going to write a ratio. I'm going to do T to U is 16. And 16 corresponds to the other longest side, which is 8. And again, T is my first letter. It's the 60-degree angle, so I'm going to line it up here. So it would be E to H. That simplifies to 2. Grab another color. I'm going to do the smallest one, which is 10 and 4. 10 is T to S or S to T. As long as you're consistent. T to S is 10 centimeters. T, which is my 60-degree angle, again corresponds with the 60-degree angle over here. So it's E to D. And the length of E to D is 4. If I were to simplify 10 over 4, I'd get 5 over 2. Do these ratios form a proportion? They do not. Therefore, you are done. Okay? And remember, we had to explain. So your explanation would be something along the lines of, it is not similar because the lengths are not proportional. Okay. Okay, we are running out of time here, Panther, so I'm going to stop you here. Please continue on to the next video.